Hi for day 2. I just want to recap what A, H, and K are again. So remember your A value tells you a lot of things, right? If A is greater than 1, it's a vertical stretch. If A is between 0 and 1, it's a vertical condense or compress. And if A is negative, then it reflects over the x-axis. And then you have H. Remember, H is on the inside, so it's attached to the X, so that means it's moving left and right. Okay, it moves left when it says plus H, and it moves right when it says minus H. Okay, remember, it's always opposite of what you see. Whereas with the K, if it's plus K, you're moving up. If it's minus K, you're moving down. Okay, so let's use all of those to start graphing these transformations. So we are going to start by identifying the vertex. So our vertex is at -4, 3. Okay, and sometimes I make a V instead. So we have it like that. Okay, so from here, we are going to identify our axis of symmetry. So our axis of symmetry is going to be at x equals -4. So it's always going to be whatever this vertex x value is. So I'm going to go to -4 and I'm going to put the axis of symmetry and I'm going to plot that point, -4, +3. Now we have to identify our domain, our range. We need to think about what this -2 does. So first off, domain is always going to be -infinity to +infinity. But we need to figure out what our range is, and that's going to help us, what's going to help us is graphing this first. So this -2, remember, is your A value, right? And your A value tells you how you're moving. Okay, it's kind of like your slope here. Okay, so normally if it's a -2, we would go down 2 over 1, down 2 over 1, and so on, right? So we can plot it all the way through, or you could do the majority. Now, think about the axis of symmetry. It's supposed to reflect. So that means that on this side, we would go in the opposite direction. Okay, absolute values are not linear functions, so they are not going to be just a straight line. It has to go one way and then the other. So now we can think about our range. Our lowest y value is -infinity, and our highest is right here at the vertex, which is 3. Increasing and decreasing is always our x values, so I always just start on the left. -infinity to your axis of symmetry, which is -4. That's going to be increasing, so -infinity to -4 goes in the increasing, which means the rest of it is going to go decreasing. So when you want to describe the transformations, first off, our A is 2, which means vertical stretch of 2. But it's also reflected over the x-axis because it's negative. The +4 means left 4, and the +3 means up 3. So we're going to do another example like that. In number 2, we take out the vertex, +1, +2, which means that our axis of symmetry is at x equals 1. You can also automatically fill in domain because that's what it's always going to be right now. 1, 2 is my vertex, and my axis of symmetry is right through it. You don't have to draw that line if you didn't want to. Now, we're going to use our A value to help us with our slope. So we go up 3 over 1, up 3 over 1, and reflect it over. So we have a much steeper V. This time our range, our lowest, is at 2. Notice how it always matches our Y value here. And our highest is infinity. Again, increasing and decreasing, x values and parentheses. So from the left, we are going down. So that means from negative infinity to our axis of symmetry, which is at 1, we are decreasing, which means the rest of it we are increasing. So that would be from 1 to infinity. From there, our transformations, the 3 is a vertical stretch of 3. The -1 means right 1. The +2 means up 2. For number 3, we start off the same way by taking out our vertex. There is nothing on the inside with our x, so if there is nothing there, it would be a 0, not a 1. If there was a 1, it would say -1. And then obviously -3 is our y value, so 0, -3. Again, our axis of symmetry is always x equals whatever this x value is. And this -3 is going to be used in the range at some point. Also, our domain is always negative infinity to positive infinity. So now, we want to use our a value as our slope. So we would go up 1 over 2, up 1 over 2, and so on. And then we need to go and reflect it. Up 1, left 2, up 1, left 2, and so on. So now our range, our lowest value is the -3, and our highest is infinity. Increasing and decreasing are our x values. To the left, we are decreasing. So that means negative infinity to our axis of symmetry, which is at 0, is going to be the decreasing, which means from 0 to infinity, it's going to be the increasing. Transformations, there's a vertical compression of 1/2, and you move down 3. Last couple problems. This time, we're given the graph to the right, and we want to write the equation. So the big thing is focusing on this 4, 1. So obviously the 4 is going on the inside with the x, and the 1 is going on the outside. So we have y equals, and I know it's going to be x minus 4 and then plus 1. Remember, it's always the opposite of the x value. So it says positive 4. Gosh dang it, I'm trying to highlight that. Positive 4, so we want -4 in our equation. The only thing we have to think about now is our slope. So we have to think, we start here, we go up 2 over 1, which means my slope is 2. Domain, farthest left, farthest right, it's going to be negative infinity to positive infinity. Our range, our lowest y value is 1. Our highest y value is infinity. And then increasing and decreasing. You can also just look for the increasing part first. That would be from your axis of symmetry to the right. So that's from 4 to infinity, which means negative infinity to 4 would be our decreasing. So it says for number 10, given the graph to the right, write an equation that represents the function. Then in part B, it says write an equation of a new function that moves to the right, translated 1 unit right and 4 units up. Okay, so first let's write an equation for this one. My vertex is at -1, 2. So that means we're going to be with x plus 1 plus 2. Only thing left to do is figure out our slope. If we pick this point and this point, we would be going up 1, 2, 3 over 2. And that would be our equation. For the next part, you can do this multiple ways. What I'm going to think about is moving my vertex. So we're going to look at this graph again, and I'm going to start with my vertex, and I'm going to move it 1 to the right and then 4 units up. So I would be right here. So now I can put together an equation knowing that it would be y equals x and then plus 6 because that vertex is at 0, 6. You're welcome to put x minus 0 plus 6. That's not incorrect. Now the only thing we have to think about now is our slope, right? Well, nothing happened in this equation with our slope. So that means our slope is going to end up staying the same. It's not going to change how it goes.